So good afternoon, everyone. Welcome back to the day 1, session 3 on of a faculty development program on Industry 4.0. So now we are having the session 3, hands-on on Labview and virtual instrumentation. So the key resource person for this is Vasant Kumar V. So I'll just take 2 minutes to introduce him. So Vasant Kumar V graduated as Electronics and Communication Engineer from Anna University, Chennai. Currently designated as an Assistant Manager in VI Solutions, Bangalore. It's around 8 years experience in NI technology. He is also handling the major responsibility of supporting various industries in implementing several turnkey systems and system integration projects using NI technology. He is also handling the major responsibility of improving the quality of engineering and science education and eradicating the impoverished method of education and inculcating the interest for Labview. Vasant is the first and only certified professional instructor for INDRAA, that is India, Russia, Armenia and Africa, National Instruments and CLD certified. Has traveled far and wide throughout India and has delivered thought-provoking lectures and kindled people interest towards Labview, and also visited more than 150 Indian engineering institutions and industries. He had conducted more number of hands-on trainings to industrial experts of various domains in Labview basics and data acquisition. He has also conducted many faculty development workshops on various trending technologies, including digital image processing, data acquisition and control, etc. He has delivered 200 plus lectures on experiential engineering education on varied technology topics. Vasant sir's key interest areas are embedded system, automation, digital image processing, sensors, data acquisition and signal conditioning, wireless sensor networks. So I welcome you, sir, for this session. So you can take over the session, sir. Thank you.
Thank you so much, madam. First of all, I'm really delighted to be part of this training program. So, and I'm here to give a basic introduction to this Labview toolkit. We actually have a plan of, having multiple sessions. We totally have nearly 4 to 5 sessions here in a hands-on program on Labview. So I have 2 sessions. I'm glad that, I can come back to you people. So where that is going to be on the 5th day on the Friday, where, I'll be handling you people about, the Industrial Revolution 4.0. I'll get very depth in there. So today I'll be giving you a glance of how NI technology is being evolved over time, and what are the verticals they concentrate to get into the automation sector. Where I'll also be giving you a basic hands-on program. I saw even some people have just dropped a message saying that they are unable to get the Labview downloaded. In case if you're facing that issue, if you're unable to download it, I'll also send you a new link to you people, which will be more easy for you to download at the end of the session. I'll just send you that. It is okay. You can just have a watch like how I'm doing it. You can make a note of all the what are the points I'm just telling, and try the hands-on later. No issues about that. So I'll just share my screen now. Please let me know if you people can see the So just check and let me know if you people can see my screen. So I'm just showing my PPT. So can anyone give me a confirmation whether you can see my screen?
Yes, sir. Yes, sir.
Okay, man. Thank you. So one second. Yeah. So today's topic is going to be all about the graphical system design, virtual instrumentation, how to start working with the basic Labview and NI technology. That is going to be the ultimate idea. So the agenda of today's program is going to be into 3 sections. So the number 1 section is going to be the basics introduction to what is NI technology and Labview. What is it basically it is useful for? So what industries are using or doing with Labview and NI technology? What are the products they basically give? All these things will be covered in the first session. So then going to the next section, you'll be having understanding about the environment, where I'll be demonstrating you about the environment and the data types available, and I'll be started doing some basic examples like how to use it, how to create new simple applications. The reason why this is very important is in the upcoming sessions where we are going to show you people how to do a data acquisition, and also we are going to show you how to design an IoT system, how a control system is going to be done, and how Industrial Revolution 4.0 is being used, where I'll be showing you about, the advanced automation technologies. I'll be showing you all those things. There, you should be catching up with, what is that we are trying to show you, because most of the hands-on program what we have planned is going to be from Labview only. So I felt like it is better to just give you people the basics of it. So we have just put in this basics, and we want you to take the hands-on also. But it was too late for us, to give you the links, and unfortunately, I think the link is not working. I believe, I'm not sure. I've not checked it. So I'll check it out and why it is not working. If there is a problem with a specific participant, I'll just try to help that person and try to get it done. If not, if everyone is having that issue, I'll try to find out a better link to download the newer version. Usually the problem is where Labview National Instruments keeps on upgrading the new version of Labview. Every year they try to launch a new version. What they do is they stop supporting the older version. The version sent to you is 2018 version. The recent version launched is 2021. Maybe they have stopped the support. I'm not sure. Maybe I have to check the link why it is not working. In that case, I'll just send you a newer version so that you people can start using a newer version. I'm using 2019 for all the demonstration. It is pretty similar. The features might be in advanced level. It's slightly different. That is all it is. Apart from that, it's all same. All right. So third section is going to be about how a decision-making algorithm and iterative structures can be designed using Labview. So this is going to be the overall agenda of today's program. And I want to just give a instruction, like, in case if you're not following anybody, I want you to abruptly stop me and just get it clarified, because moving further, if you're not following anything, and this is, as I told you, this is going to be the introduction section for all the upcoming 4 or 5 hands-on sections. So it is going to be a very important section here. So I would suggest you people to get it clarified, make sure that you'll be able to do it. And I would wish you people to take a hands-on also after this session. You can make also note of all the topics which I'm just trying to show you. And obviously you can come back. I'll be sharing my contact detail also, in case if you're facing any issues on your hands-on time, please let me know so I can help you people out of it. All right. So I'm just quickly moving into section 1. I don't know how many people have heard about this toolkit, or a platform where most of the automation is carried out globally. All right. So if you see all leading company, I'll be showing you what are the companies they're using. To some extent, I'll just try to explore you people about what are the different types of technology they use, what are the different companies are using, on what perspective they're using them. I'll show you. Before that, I want to introduce you people a company called National Instruments. So they are a leading global automation designers. So basically what they provide is they provide solutions for all the engineering problems in industry level. So they are like they provide hardwares, so like data acquisition card, PXA card, CRO card. All these cards are like for embedded application, image processing application, RT applications. For all the applications, they try to provide some hardwares, and they try to program them using Labview, a toolkit called as Labview. So Labview is going to be today's agenda. So I'm going to quickly show you, because in upcoming sessions, we are also going to bring in some of the hardwares and show you how to do a data acquisition. Also, we are planning to show you. So this is going to be the basics of that. So if you people have heard about National Instruments, it's well and good. If you don't know, I'll just quickly give an introduction to you people, how they have evolved. So they were, the Labview National Instrument was launched in the year 1976, very first. All right. So it is headquartered at NIUS. So it is in Texas, Austin. So from there, they were into basic data acquisition systems like GPIB, general purpose interface bus. That's the very first thing they launched. And from there they expanded to all the domains, especially they have very predominantly used in automation. From there, yes, they are now into even the HIL systems. They are into designing 5G sector. Most of the 5G based application research works are also carried out using NI hardware. All right. So they are now into everywhere. Going further, I'll be telling you all about that. So the very very best highlight of National Instrument product would be their hardware plus software, both, right? And they're very easy to program. Today I'll be showing you all about. So Labview is the Labview. Labview stands for Laboratory Virtual Instrumentation Engineering Workbench. You can see in the screen. So laboratory virtual instrumentation engineering workbench. That's a toolkit name. That is the name of the platform which you are going to do it. So it is a graphical programming language. What do you mean by graphical programming languages? We people have done other programmings, like C program. We have done MATLAB programming. We have done HTML programming, Java even. So all these programming are textual programming. What is meant by textual programming is very simple. If you want to program something, you type your programs. You just make a commands based on textual words, right? So hash include stdio.h. These are like command words. So when it comes to Labview, not only Labview, there are much more toolkits or like much more programming tools which are working out as a graphical programming, where you draw your logics, you drag and drop them, connect them together, and make it run together, and then it's going to make your program execute, right? Making it more easier for the freshers to do it. So ultimately, what is the highlight of this type of programming is, number one, if you're moving new into this technology, it becomes very easy for you to understand. The reason is Labview don't have, or not only Labview, any graphical programming you come across will not be having syntax. Syntax is a problem most of the people have problem with. All right, and moreover, since it's a graphical programming, so you drag and drop it and connect it together, it doesn't consume more time. It doesn't consume more time in developing an application, testing an application. That's why Labview is called as a rapid prototyping toolkit. All right, so it very rapidly allows you to design, test, and use the application. And what is the other highlights of this is Labview is a high level design tool. Okay, what is a high level design tool? I'll just try to give a quick example to you. Other programming language like C or assembly language, these are like low level programming language. If you ask me what is that, see, I'm a programmer. We are going to program, and what are we going to do? We are going to do a task. Engineering is basically doing some task. All right, acquiring some data, controlling some sensors, or collecting some data from the sensors, controlling a power plant, whatever maybe it is. This is just an idea of commanding some instruments to get a task done, right? So if you have a hardware you want to acquire, or you want to control, or there is a motor, you want to control the speed of the motor, let me say. So you are going to command it. As a programmer, you're going to use a tool. That is what is called as a platform, workbench. All right, Labview is going to be one such workbench. It can be anything I'm talking about, a programming tool. So you being a master, controlling an instrument is a slave here because you program it, right? So a master talking to a slave on slave language, that is basically called as a low-level design tool. For example, I can tell you, hash include stdio.h. Let me say about that, or konya.h, where you see in a real life, master, like we human being don't talk now. When I see a person, I don't say hash include how are you. I don't say that, right? So it is a machine language. Only machine can understand that, and it can understand the command and it responds to the command. That is a machine language. That is a low-level language. Now, coming to high-level design tool, I don't want to talk to the machine on a machine language because it's consuming more time for me. It is becoming more difficult for me to eradicate the errors. Debugging the errors becomes a very difficult task for me. So I don't want to get into low level. I want to stay in the high level. I talk to the instrument in the high level, and there should be a compiler which is running behind. That is very important. A compiler helps you to convert a high-level design tool into a low-level design tool ultimately, right? So I try to write a program on a high-level design tool, and a compiler which is running behind this toolkits basically gets converted to your computer level. Then from there, it gets once again compiled into binary level and get processed and come back to you as an application. Right, so this is basically called as high-level design tool. If you see nowadays in the recent time, especially, I'll also talk to you all about this in the later point of time, where Industrial Revolution 4.0, where evolving of how engineering standards are gone up. I'm going to talk to you all about that in the last session. So there also, right, I'll be telling you about the programming toolkits and the programming styles being used in industries. Right, there you'll see that many people don't want to get into the low-level design because we want high experts to do this. So now if I start looking out for the number of experts, right? Experts are always in a handful of experts. But if you see the freshers, there are a lot of freshers around, right? I want someone, or I want a tool that can be, programmed or, developed or handled by, freshers also. So that's where, NI technology, playing a vital role. The idea is good. I would suggest the idea is good, what they're trying to do. And moreover, it is very successful. That's the reason it is being used, by most of the industries. And what are the other advantages, if you ask me? It supports the support for they provide this Labview support for your computer platform, desktop platform. That's the reason we have shared the link to download Labview, right? So you can download Labview and you can install in your computer. It works for Windows, it works for Mac, I mean your Apple. It also works for your Linux OS. So apart from that, you can also, these are like computer, like what we people use. You can also deploy it into a FPGA. Okay. So many people think the Verilog, Verilog and the VHDL are the two hardware description language for, FPGA. Many people think that actually that is not right. So Labview can also be written, or you can use Labview to write a program on your Xilinx FPGA chip. So you can see here, this is a Labview program. I'm going to show you how to develop this. You can see that I'm just displaying here where you can deploy it into your Xilinx IC. All right. So many people think that Labview is not. Once again, a compiler is running behind. I'm not saying no. Everywhere the compiler is needed. If you see, if you are good in FPGA, if your background was from advanced embedded system, you'll be understanding that. So any program you write has to be compiled into a bit version. Okay. So the bit file gets generated and the bit file gets deployed there. So Labview can also be generating a bit file. All right, where you can deploy into Xilinx, and you see all the NI product which comes as an embedded hardware. For example, Cerio, Myrio, SBRio, all these hardwares, if you see, they have Xilinx chip, Xilinx FPGA, Xilinx RT running on them, where you can deploy the Labview program inside. You can also create a RTEXE. What is RTEXE? Is nothing but a real-time application where you can deploy it and make it a complete standalone, right? So Labview gives these kind of flexibility to you people. All right, it gives you flexibility to you people and make it more efficient to be used in all platforms. See, ultimate reason or ultimate goal is this has to serve the solution for everyone. It's up to you want to use this or not. That's secondary. When it comes to industries, you should give more ability. The reach should be higher. That's why the name of the lab itself says it's an engineering workbench. They don't point out exactly what is the domain they want to concentrate on. They don't do that. So it's a commonly for all engineering solutions. All right. So as I told you, these are the n number of top shot companies that use NI technology. Can be programming, can be testing, can be evaluation, verification, validation, can be anything. But overall, if you see, these many big shot companies use NI technology. All right. So what are the companies you might be knowing? And very importantly, if you notice, there are companies from different backgrounds. I think someone has unmuted. Can everyone keep it muted unless you want to ask something, or if you have any queries, you can just unmute and ask me. If not, can you just keep it muted, everyone? Thank you all. So if you see here, all the companies are from a different background. For example, let me say I can see Boeing here. So Boeing is a flight designing company. NASA is a rocket space satellite designing company. Ford is an automobile company, right? Yokogawa was an automation company where they design a lot of PLCs. Honeywell is one such same company. AMD provides chips for your computers in your internal RAMs, your graphic cards, all designed. It gets designed by AMD. Philips is an electric and electronic based company, right? So Siemens is one similar company. Right? There are a lot of companies here, but they use NI technology overall. But if you notice, what is the common thing between them? They are from different background, but one thing is common between them is they're all product-based companies. Very important. That's something you have to note it down. So these are all product-based companies. When it comes to product-based companies, there is a reason why these many best top shot product-based company use NI technology. Very simple reason is they are rapid prototype. So which means that very quickly you can design, you can analyze, you can develop an application, test it, it's working or not, debugging becomes very easy. As I told you, it is a high-level design tool and a graphical programming language. Very simple reason. All right. And for your information, I'll just also added something like, I think you people will be knowing SpaceX. SpaceX is one of a buzzing company. Elon Musk, gentleman in Elon Musk, he serves all over the social media. If you're using social media, he has, various companies. One is Tesla, which provides hybrid cars and, electric cars. It provides both. And then, SpaceX, which is basically on a space shuttle designing company. One advantage or one big highlight of this company is basically they are like the very first privatized space shuttle designing company. Most of the NASA, ISRO, whatever we come across, they're all in a private organization. All right. So this is the first company which is designing, and his ideas are totally absolutely awesome. So you can go and check about that. I don't want to get in depth about it, but I just want to bring it to you. See, this is a very new company. It's not a very old company. So very recently they have just stepped into this. So this person, I don't think so he's going to invest on anything. Okay, invest on anything which is not going to have a long-lasting application, which means that they don't invest on anything they feel like it is not going to work or it is not going to work for a longer period of time. So I want to bring you people how they use it. So they use a lot of toolkits in there. So SpaceX software engineers use a lot of toolkits, a lot of softwares, a lot of programmings they do. So when I was going through, I was able to see once that they use Labview also. I got very curious and I just wanted to check what they do. Then I was reading their profile and I was just able to see this. Okay, so I'll just quickly read it out to you people. So the ground team is about 9 people, which means that the ground software team is only 9 people, not more. That entire company where they control all the space shuttle, everything is just 9 people. We primarily code in Labview. We develop the GUI. GUI stands for graphical user interface, used in mission and control, launch control for engineers and operators to monitor vehicle telemetry and command the rocket, spacecraft, and path supported equipments. Which means that in the ground station, all the controls, all the monitoring, everything like GU design, everything is happening through Labview only. All right. So which means that it's obvious that most of the people, even newly upcoming new technology preferring companies, or like high-end technology preferring companies also start using Labview, even though Labview is like from a very old school type of programming language, because it's from 1976, right? From 1976 it's been used. The only advantage of Labview, why most of the people want to use this, is very simple. They upgrade it every time, which means that every year, I told you in the beginning also, I was telling you, every year they upgrade the software, right? So that's the reason you see a Labview version based on the year. Okay, 2018 Labview, 2019 Labview, 2020, right? The very recently released is Labview 2021. That is the latest software you have. There is also a bug removed version called as SP1. So Labview 2021 SP1 is the latest version of Labview. A newer version of Labview 2022 will be released in the August month. Always they release one software in August month, and they'll give a beta version well in advance, which will be used only by the community, like Labview developers. There are certification we have. So based on the certification, it will be circulated to the community people, and they'll come up with good solutions, some suggestions, feedbacks, where a lot of problems can be eliminated, so that the beta version gets released in the month of April itself, and the proper version gets released in the year of August, in the month of August. Sorry. Okay. So the latest version is 2021. So you people, I'll try to find out which is the latest version, and I can share you the same. So it will be a trial version for you people. All right. So there should be a reason why Labview is being preferred by these many companies, right? Because very simple, like most of the product-based companies have been using. Obviously, there is advantage. Very quickly, I'll just compare it. What is the real-time reason why people prefer it? Okay. So just see, this is a C program which is doing addition of 2 numbers, because you can see that it's C equal to A plus B, which means that it's doing addition of 2 numbers. You're supposed to specify what is a A value, then you're supposed to provide a B value, and the program is going to calculate the value of A and B, and it's going to show you in the variable name C. That is what it's going to do. So that there is a blue color screen in C program where you type all this code, textual programming, you type all this code, and then you compile it, and then you execute it, right? So once you execute it, okay, that there's a black color screen is going to come up where it will prompt you to type your your inputs, and it will show you the output. That is basically called as a UI screen, user interface screen, where the developer will develop the code in the blue color screen. Okay, that is the environment. So then what happens is, once you compile it and execute it, it will be executed, and the black color screen comes into picture. It is more similar to your what I can say is your ATM machine. You have been to ATM machine. So in your ATM machine, if you see, you try to provide your inputs, and the machine on the back end will execute and give you the output, whatever may be the output, showing your bank balance, or your PIN number change, or whatever it is, it will be showing you, right? So whatever you see here at the top, this is the programming window where the program is available, and this is the UI screen. All right. So what I'm showing now is a Java program. So you can see here, Java is also doing the same thing, sum equal to A plus, which means that it's adding 2 numbers. All right. So if you see in the recent time, I can just go 10 years back in the industries, where you can see that the opening for Java was more, because many people started doing Java course. Many people, even I know some of my relatives were doing them. So when I was in school days, like 15 years or 16 years before, there you would have seen people badly want to do Java, .NET also, not only Java, .NET also, and they were having more scope for that compared to C. Okay, what was the reason Java was predominantly being used over C? Because just imagine from a perspective of a company, they have C team, they have a Java team. Let me say a big shot company. Let me say they have C team, they have a a Java team. So when it comes to task, they prefer Java. The ultimate reason is from company's point of view, both are gonna at the end of the day finish the task. There are different specifications, there are different advantages technically. I'm not talking about technically. From a company's point of view, where capital cost is a very important criteria, they want it to be completed within a given period of time. They don't want to drag it beyond the period of time. So in that case, what happens is Java basically consumes lesser programming lines. Very simple reason, it consumes lesser programming lines. You can see, compare the same example like C and Java. You can see Java has consumed like nearly 4 to 5 lines of codes lesser than a C program. Same task, doing the same task. You can ask me what is the big difference in 4 to 5 lines. There is a huge difference, I'll tell you. It's just a simple addition of two numbers. Let me talk about a very big application for the same ATM machine, let me say, or any of the online booking app, for example, Book My Show, let me say. So it basically takes your location, it tells you what language you want, you choose the language, then it lists out what are the theaters around, and what are the movies playing, what are the shows you have, how many tickets you want. You can select it, and then your payment comes into picture. Payment is of different types: card, debit card, wallet, credit card, the different methods, UPI, right? Then your passwords, your OTP goes to your phone. The phone sends the OTP to you, and you can put it in, and then you can log in. And on the database, it has to be blocking your seats, right? And that has to be mailed to you. So this much process is involved in one single customer. I'm talking about one single customer. Just imagine they are now taking care of this entire India. How many people will be using this Book My Show? They are having a database which is trying to run on them, and an app which is running on them, and it is trying to take care of everything, right? Just imagine the primary code which is running on this their server. Okay, because these are all like these apps doesn't work without internet, that, which means that it is basically server based. So how much lines of code will be involved in that, how much time they are developed, they involved in developing, how many people would have been involved, how much time they are taken to validate, debug, and how much bugs would have then come across. They have to sort it out, and one particular version of software to get released, a lot of problems you'll be facing, right? So just think, if the same application was done in Java compared to C, how many lines of code they would have preserved, right? They have not consume these many big team. The number of size of the team also matters a lot, because the more the size of the team, the more the amount of people involved, more complex it turns into, and more my wages also go, because I have to invest a lot, right? So that's the reason Java was having more scope compared to C. Now I'll quickly show the same application in Labview. So whatever you see here is two windows. One is a front panel and block diagram. Front panel is nothing but is your UI screen, where it prompts you the inputs and gives you the output. Okay, it prompts you the input and gives you the output. Block diagram is the replication of this coding, whatever you see. C program, Java program, this is Labview program, whatever you see. It's a graphical program, I told you. You can see that it's simple, where you have two inputs, X and Y are the inputs. X plus Y is the output variable name, and it is getting added. And you can clearly see Labview concentrates only on the actual application, adding two numbers and putting into a variable. That's what it's doing here. C equal to A plus B, in sum equal to A plus B. Labview will be concentrating only on the actual application. Anywhere you see, the size of this particular application development is same. Okay, size of application development, that actual core requirement, technically it is same. That doesn't change. But the size of the syntax being used to make this line of code to execute varies, right? When it comes to Labview, it is nearly zero. It is nearly zero, where you don't have any syntax. You'll be directly working only on the application, making it more precise to the point, whatever you want to design. That makes it more easier for us to design. You understanding? Yes. So on that case, if you see, Labview has been used by various domains. Various domains have been used, and this time we'll be concentrating on few domains like IoT. We'll be concentrating on Industrial Revolution 4.0. We'll be concentrating on 10 and 11. We'll also be slightly concentrating on control design, and we'll also be concentrating on data acquisition system. The first point, data acquisition system, and you can program them using for NI card and non-NI card also, if the drivers are available. All right. So a lot of applications can be possible. The very recent technologies were getting added. I'll just tell you this. artificial intelligence, neural network, machine learning, deep learning, smart grid, ECU, ECUs, PMU, sorry, phasor measurement unit, and electrical power suit. IoT is a new one. Then communication-wise, 5G research is happening. There's a hardware you don't do your N-cross and MIMO. Then you can also do your CAN, LIN, flex ray. Then you can also go for R-ing protocol, military stand 1553 protocol. Most of the applications are possible. I'll also be coming back to you people about Industrial Revolution 4.0, smart factory design. All these things I'll be telling you how these companies, whatever I was showing you, right? Those companies, how they were, designing before, what is the current technology they are using, and what is the future technology they're planning to turn their companies into, the production department into. All these things comes into picture. So I'll quickly go for a demo to you people so that you people can see how Labview can be used. So I'll quickly launch Labview. So this is how a Labview window looks like. Okay. So any queries to this, because I'm going to show a simple demonstration. Any queries anyone have? I'll just quickly come to the.
Can I ask a question?
If anyone is having any queries, you can ask right now.
I have a question.
Yes, sir. Yes, sir. Please.
I have installed the version shared by email, the 2018 version of Labview. It is in fact installed as a 32-bit application. So I wanted to ask the presenter if Labview is only a 32-bit application or just the version we received is a 32-bit version.
Labview gets released in both the version every time, 32 and 64. Okay. So 32 runs on both 32-bit version of computer and also 64-bit version of computer. But a 64-bit version of Labview works only at 64-bit of computer. All right. We have shared you 32-bit version because some people might use 64, some people might use 32-bit of computer. Nowadays, if you see, all computers are coming at 64-bit only. The software we shared is 32-bit software. It works in both the computers. But actually speaking, it is also available. 64-bit version of Labview is also available. When you search it in the Google, also when you search it, you have to mention it as 64-bit. Normally, it comes in 32-bit only. The trial version, beta version, everything comes in 32. The actual version, when it gets launched in the August month every year, gets released in both the version. Clear, sir?
Yeah, and how many cores can Labview utilize in a computer?
How many cores it can use? If you're having 4 cores, it can use all 4 cores. There is a technique where you can concentrate on the threads allocation, and you can make sure all 4 cores can be accessed. That is possible. You can program it which core to be handled. Normally, it can use all the cores. Okay. But you can also program by setting the priorities and making sure no particular core can handle particular task. That is possible, sir. Sure.
So we have two more questions in the chat. If you see that, first one is how Fpga is comparable to Labview, and the second one is can Labview be used for Fpga?
Okay, so Labview can be used for Fpga commonly. For the first question, it asks how Fpga is comparable to Labview. Labview is a programming tool. Fpga is a chip. Okay, Fpga is a chip. You have to do a HDL program, hardware description language, to program a Fpga. All right. So what actually happens is the program, whatever you design, gets imprinted on the Fpga. It erases the previous programs, and you can, if you wish to erase, you can erase it, and you can just deploy this particular code and make it a standalone application. That's what Fpga does. So many people think only HDL. When I talk about HDL, hardware description language, people think there are only 2 different HDLs available. One is Verilog and one is VHDL. Okay. So only 2 things are available, people think. But actually, Labview can also be used, where what happens is when you write a program, Fpga program on Labview, it gets converted using a compiler. We have a compiler. Xilinx provides a compiler for you for Labview. Compiler for Labview, not the common compiler. Okay. So that compiles a code and gives you a bit file, and that bit file can be imprinted on your Fpga and make a standalone. So that's how you can do it. So I think both the questions are answered when it comes to the question. So how Fpga is comparable to Labview? It is a hardware and this is a software. You can write a Labview program to deploy it on a Fpga. That is the answer to the first question. Second question, can Labview be used for Fpga? Yes, it is possible. Xilinx Fpga, it is possible. Okay, so predominantly Xilinx Fpga is what is being used. Apart from that, some customized Fpgas are there. But Labview is basically for wherever you can use a VHD and Verilog, Labview can also be used. That is a simple answer to that question. Okay. So power consumption option is a viable there. I'm not getting you the question actually. Available there you're asking. Power consumption option is available. Power consumption of what, sir? For FPGA you're talking about. Power consumption of FPGA you're talking about is available there. Basically, you can't handle the power consumption, but you can monitor the how much power consumption you can basically. Yeah, I understand. I understood for model development. So power consumption can be monitored. There is option to monitor the power consumption, but basically you can't control it. See, let me say you want to make it a far better solution. You have to change the logics and just generate a code bit file and try to implement on that, and you can see the power consumption. That is possible, but apart from that, you cannot write a program to make it better. That is not possible with Labview. I'm not sure whether it is available in HDL, but in Labview, many people have asked me about this. Power consumption, resource consumption, because you want to know how many gates are being used, right? So whether it is a feasible application, how much memory footprint is being occupied, all these things people used to research. So thank you, sir. So Labview, I'm not sure whether it can do that, but you can monitor it. That's for sure. You can monitor it. That's for sure. So if there is no much queries, I'll just quickly go for the demonstration. You people can feel free to write the queries whenever you have. Hardly every 15 to 20 minutes, I'll come back here and I'll check your queries. I'll answer them and I'll go back. No issues about that. You can feel free to write it, or you can interrupt me and you can ask me. No issues about that. All right. So I'm just taking a Labview. When you people launch a Labview, what will happen is it will say it is a trial version. Okay. So it will say for you it is a trial version. So you have to launch the trial version and you have to use it. So it will say that no, that it is going to expire within 7 days, and you have to launch it and you have to keep using it. All right. So this window, whatever you have, this is called as a getting started window. For newcomers, this is very important. Just watch here. I'm just gonna. You'll see that in the upcoming session also, everything starts from here. So if you want to generate a new EXE file, if you want to write a FPGA code, if you want to write a hardware control code, whatever you want, virus creation, antivirus creation is also possible with Labview. Installer file creation is also possible with Labview. It is being used for all the engineering solutions I told you. IoT application is possible. Industrial IoT is possible. Protocols are possible. I was talking to you all about the communication protocol, 5G research. Everything is possible, but everything starts from here. That's why the name of this window is called as a getting started window. All right. So once the getting started window is available to you, just click File, New VI. So very first option you get is New VI. You have a shortcut also. Control N is New VI. All right. So when you do that, what happens is a new workspace will be launched. Can you see workspace is launched, and it's basically named on how many you have previously created. I have already created 7, and it takes untitled 1, 2, 3, 4. It keeps going. So you see 2 windows every time I launch a new VI. A VI is a combination of 2 things. One is front panel and block diagram. I repeat, when I say new VI, you see 2 windows appearing. One is front panel and one is block diagram. It's a combination, front panel and block diagram. So I'm going to press Control T for tiling up side by side. Okay. So you have an option, Windows, tile left and right. Can you see Windows, tile left and right? So creating a new VI is File New VI. Can you see here? I'll close it. If I don't want it, I'll close it. So Windows, tile left and right. Getting it? So what happens is by pressing Control T, your window gets aligned themselves in such a way that 50% will be occupied by your front panel, 50% by your block diagram, so that we'll be working on both. Okay, we'll be working on both. I'm going to quickly show you how to create inputs, outputs, some simple application. I'll just show you. I'll keep to a very simple example or very simple demo which I showed you. Addition of 2 numbers we saw, right? I'll try doing the same thing. Just watch. So to do addition of 2 numbers, I need 2 inputs, 1 output. Right? 2 inputs, 1 output. So in Labview, make a note of it. It's very important. In Labview, inputs are called as controls. Outputs are called as indicators. I repeat, in NI technology, not only in Labview, in NI technology, inputs are called as controls. Outputs are called as indicators. And I'll tell you, you can ask me why it is named like that. I'll tell you. Basically, NI technology handles both hardware level and software level, which means that real-time version and also a simulation version is possible in Labview. All right. Right now, I'm not using any of the hardwares. A real-time signal will be considered as an analog input signal or analog output signal, digital input signal, digital output signal. A real-time signal will be considered as input and output. Okay, I repeat, a real-time data will be considered as input and output. When there is a simulated versions, simulated, now we are not having a hardware. I'm going to do a software level application development now. So there, I'm going to call it as controls and indicators only. Just to, make you people identify that, whether it is working on a real-time application or a basic software level application, then, it is basically called as, controls and indicators. So right click on front panel. Front panel is a place where all your inputs and outputs are available. So your UI will be designed on your front panel. I repeat, the UIs will be designed on the front panel. UI is nothing but user interface. So when I talk about user interface, it's very simple. Inputs and outputs, some messages if you have, some prompting if you have, all these things will be done on the front panel. Block diagram is a place where your actual logic takes place. Your logics, your arithmetic, your technical part, everything will be taken care in the block diagram. And you can see that is the reason on the front panel you have grids so that you can align your codes. You can align them based on the margin, size, measurements, everything. You can do it and you can align it here. So it has some grids, whereas block diagram, you don't have anything because your customers will not be seeing your block diagram. Your customers will be seeing only your front panel. Clear? So very quickly, what I'm going to do is I'm going to right click on the front panel. When I right click, you have a controls palette. Right click anywhere on the front panel, you get a controls palette. Same like if you right click on the block diagram, you get a functions palette. I repeat, when you right click on the front panel, you get a controls palette. You right click on the block diagram, you get a functions palette. So if you want to drag and drop any UI item like control, indicator, prompting window, everything, if you want to design, then you have to design it on the front panel. If you want to do some logics, then you go for a block diagram. All right. So right click on the front panel, you have controls palette. If you notice on the controls palette, what you have is you have all the inputs and outputs classified based on their data types. I repeat, all your inputs and outputs are classified based on their data types. So now I'm going to do addition of two numbers. So I'll go to numeric control and numeric indicator you have. So if you wish to go for some other different types of a pictorial representation of your numerical analog data, you can go for anything you wish. I'm going to simply go for a digital item, like new analog numeric item. So I'll just drag and drop a numeric control like this. I'm going to name it as A. Any name can be there, a variable name. So input A, and I need one more, drag and drop. I'm going to name it as input B and numeric indicator and output C. So numeric controls A and B. Numeric indicator is your C. Your C is a numeric indicator. All right. So slightly, I'll just make it slightly bigger for you people to see it. You can design it, you can align it the way you want, the fonts you want to change, the colors you want to change, right? Everything is possible. You can do whatever you wish, but I'm not going to concentrate more on them. I'm just going to come back to the programming part. All right. So here, if you see, your controls will have the increment and decrement button so that you can change the values here. You can also put your cursor and type whatever value you want, you wish. All right. Even here, you can also give fractional numbers, right? And added data, I want it to be updated programmatically here. So I'm going to do it in the Labview program on the block diagram. All right. So to do this, I'll come to the block diagram. Here, you can see your inputs are having arrow marks. I can slightly zoom in to show you people. I'm just zooming in. Okay, this is the zoom in version of your block diagram. You can see that your inputs are having A and B. Inputs are having arrow mark facing outward, right? And C is an indicator which has an arrow mark facing inward, outward and inward. It talks about the data flow. So these are like source items where it is sourcing the element, sourcing the data. So what I said, 87, that data gets flown from here. And there I just gave a fractional number like 7.6 or something that gets flown from here. And you have to do a logic, get added up, and that output should be sent here, and that will be visible on the front panel. All right. So in this case, what I'm going to do is I'll right click on the block diagram. So which one I feel it's going to be helpful for me is I'm going to go for numeric. I have all the items which is related to mathematical arithmetic operations. All right, numeric. Right click on the block. You will not get that option here. In this numeric, on the controls palette, numerics will have only inputs and outputs. On the block diagram, you have functions palette. There you go, you have all the arithmetic items. So I'll drag and drop a add function like this. Right? So you have inputs, you have output, you also have a function to do the wiring. Just watch. I'll move my cursor here, touch this terminal and click here. Move here, touch it, click here. I'll just show you again. Touch it. Can you see the terminal blinks? When I touch it, the terminal blinks. It means that you're touching the connecting terminal. It's called as a hotspot. HOT, hot, SPOT, hotspot from here to here. Right. So what happens is, whatever you specify here, that flows from here. Whatever you specify here, that gets flown from here and gets manipulated, processed, and the output will update the C, and that value will be displaying here. All right. So how to make it happen? How to make it execute? Here at the top, you have, title bar, menu bar, and then a toolbar. Title bar, menu bar, toolbar. This is common in all, even in your Word, if you see it is common. Okay. So I'll come to the toolbar. I have the very first tool is to be your run button. So when I click on run, what happens is the code executes and you'll get the output. All right. So if I change the value again, can you see I'm changing the value? It is not executing. It is not, showing the output. Why? It's not executing. So I'll click on the run button again. You can see the output is available. All right. I'm giving a negative data. When I run this, you'll see the output coming. So now let me say I want it to be updated spontaneously. So whenever I change the value spontaneously, this indicator should be updated. Then I'll use the second item called as run continuous. The symbol itself shows, it is running continuous. I'll click on this. I'll change the values. You'll see that it is changing spontaneously. And you can see the grids are vanished. In the run mode, the grids will be vanished. All right. So you can see it is completely executing. Any changes I do, it is updating simultaneously. If you want to stop the code now, click on this again. It will stop. Clear how this works? Any queries on this, how to do it? Any queries? I'll quickly come here. Is anyone having queries? It's a very simple application. Drag and drop them, then connect together. Any queries, anyone?
No, sir.
All right. Nice. So if there is no queries, I'm also going to quickly show you some more things like, how to delete some items. I showed you how to create them. I didn't show you how to delete it. Just watch. If I wish, I want to delete this particular B terminal, for example, I'll click, drag an arrow across. You can see, click, drag an arrow across them. A box will be generated and you can see the item is selected. A dotted lines mean it is selected. Press delete. It deletes the terminal and you can see it is connected to front panel also. You know that, right? So even that gets deleted. If you press Ctrl Z, it comes back. Undo, redo is there. Okay. So to undo, press Ctrl Z. So Ctrl A is select all. Okay. So now let me say if I've deleted this, I'm deleting it. So you can see the arrow which was connected, the wire which was connected, it is now not connected to anything. See, if a wire is not having any connection, the wire is not having any connection. It is on the other end, it is connected. On this end, it is not connected. So this is called as a broken wire. I repeat, this is called as a broken wire. A broken wire in Labview is an error. Can you see the run button is broken? Without run button, you can't run it. When I click it, it says what is the error? The error says number one error, add contains unwired or bad terminal, which means that this add function is not having any input on the second terminal. There is one more error. The wire connects to one or more data sync as but has no source, which means that it has sync. It is connected to the terminal in the one end. The source end, it is not connected to anything. All right. To remove broken wires, you have a shortcut. Press Ctrl H. Sorry, press Ctrl B. B for broken wire. Ctrl H is for help. Ctrl B, remove broken wires. All right. So if you want it again, you can drag and drop it. All right. Give a different name or like same name you wish, and then wire it. All right. Very importantly, on the front panel, on the block diagram, you'll see that the arrow marks for controls, the arrow marks are outward. For indicators, arrow marks are inward. That's very important observation you have to make. Clear? And if you wish to save, file, save. File, save. Normal, like how you do it, right? So if you wish to save, you have to go for, the particular folder. I have created a folder for you people. So here, I'll name it as add, and I'll save. So you can see the extension is .vi. The extension it takes is .vi. VI is a very important word. VI stands for virtual instruments. Okay, so VI. I'm coming from a company called VI, virtual instrument. Okay, so okay, so you can see that it gets saved, and you can see that both front panel is also saved, block diagram is also saved. So you have option to save it from both the places. File here, file here. You can save it from both the places. Even the run button, you have run here, run here. Don't think you have to do it twice here. If I click on run button, this will run here, and to make it execute, I have to come and execute here. No, not like that. When you click run button or click save, it is for both the windows. Together, it's called as a VI. For your feasibility, it is available in both the windows. All right, clear. So if this is clear, I want to quickly show you one simple video to you, how NI technology has been used in industries in the year 2003. This video which I'm showing you was done in the year 2003. It is very quite interesting video. I'll tell you what is this video is all about. This is a pencil sorting video. I'll tell you what is this pencil sorting video is doing. Pencil sorting mission is doing, first of all. So you people know Nadraj pencils. How does a Nadraj pencil look like? Red color with black stripes, right? That is how a Nadraj pencil look like. Yes. So the color pencil of Nadraj, if you see, red pencil will have a plain red color, green pencil will have a plain green, black pencil will have a plain black. All right. So that is how Nadraj pencil looks like. One simple demonstration I'm telling. Right. This is done for not Nadraj pencil. This was done by a company called Soliton in the year 2003, using NI technology, using Labview and NI technology. They use smart camera in the year 2003. Okay. So to a company called as Hindustan Pencils. Okay, Hindustan Pencils, that is the company name of this pencil. And here, what is the difference is, it is more similar to the normal Nadraj pencil, but the difference here is, you'll see the skin color is all same. All the skin color of the pencil is wooden texture without any paint on them. I think maybe they don't have much budget, so they didn't paint the pencil. So you see that red pencil will be wooden color, green will also be wooden color, black will be wooden color, pink will be wooden color. Only difference is the lead will have different colors. Lead inside will have a different color. The skin is all same. Now, there's a big challenge here. I'll tell you what is the challenge. You produce pencil, thousands and thousands of pencil in 1 hour, let me say. Okay. And your production is happening in one place, and your packing is happening in a different department. Packing department is a different place now. So now what happens is, before giving to the package department, the production department has to segregate them color-wise and give them. Why? Very simple. Package becomes very easy. One from this pencil, one from this pencil, one from this pencil, and make a packet. Okay. So we have to segregate them all, color-wise and give them. The problem here is, manually, if I do it, it becomes a slow process. Number one. Number two is, it is very difficult to do it because they are not different in the color. I mean, the skin texture is, basically made out of, skin. Wooden color. Okay, the normal pencil, wooden pencil color. Okay, so you have to look into the observe the lead color, and you have to do it, and becomes very difficult for us to do it. That is why automation comes into picture. This is a semi-automated system. Just watch here how it is happening. You can see all different color pencils are put in a very big basket, like thousands of them, 1,000 pencils are here. You can see all of same skin texture. Okay, they get aligned on the conveyor belt randomly. Just watch. So this is randomly getting aligned on the conveyor belt. No one knows in what sequence they get aligned. Randomly it is getting aligned. They use a camera now. Can you see a camera? The pencils are kept. You can see the pencils here. The pencils are placed, or the setup is made in such a way the camera will focus on the lead color. pencil is arranged in such a way it exposes the lead color. The camera will capture the information. The camera will now know on the lane, on the pencil lane, what is the first pencil color, what is the second pencil color, what is the third pencil color. It keeps noting all the information. This is a slow motion actually. Actual speed will be something like this. Then you have a digital control solenoid. Okay, what it does is the solenoid, it's an air pump solenoid. What it does is when you give a high pulse, it opens the solenoid, move out, the high pressure air and push the pencil outside the lane. Okay, and it will target only one color. You can see there are multiple air guns, each targeting a different color. On the left side, you can see. This is the Labview front panel. You can see the user uses only the front panel. He is using this. The user is using only the front panel, where he'll configure all the inputs and outputs, set the configuration parameter, everything he'll set it here. Yeah, this is basically a vision inspection system. They're using a camera. They were inspecting, what color pencil, and based on that, they were segregating. This is how NI was using automation. I'll also show you one more interesting thing. So I'll play this video.
Hey guys.
This is a interface, Labview interface with the existing gaming, and they've designed an application. Just see, it is very interesting.
Welcome to Labview Lab. This time we're going to use electrodes, Labview, and a single board Rio to play video games with our eyes.
Did you know your eye is polarized? The back of your eye is more negative than the front of your eye because of a large population of neurons on your retina. As your eye moves, the electric field surrounding your eye will move as well. We can measure these voltages by placing electrodes on the left and right side of your face. So if I look one direction, we measure a positive change. If I look the other, it'll register a negative change. Likewise, we can place electrodes on the top and bottom to measure looking up or down. Because the voltages we're dealing with are very small, there's a ground electrode placed behind the ear. This provides a reference with which to compare the other voltages. This type of measurement is called an electro-oculogram.
Now that we have these electrodes on my face, how are we actually going to turn that into an intended solder card that we created that has a circuitry that can amplify that signal. Then we can on the bottom, we can work video real-time here in that Fpga. Now, back out to our single board Rio.
So you can see that it was basic a simple data acquisition system. It was a ECG, right? It's more similar to OCG, where you are not trying to collect the data from the eyes, and we are showing a control of your joystick. Basically, we have button control, right? So rather than a button control, they were using eyeball sensor. So based on that, they are playing this game, right? So we'll also show you how to do a simple data acquisition. They were demonstrating a simple data acquisition. They didn't show the programming, but they were showing a data acquisition. So we'll also be doing the same thing. Maybe in the upcoming days, we'll be doing. All right. So I'm going to quickly continue with the demonstration. Any queries till this? Anyone? Is anyone having any query? See someone. Soliton was a system integrator. They are application developer for the package department. I'm not sure now if they are doing it, but in the year 2003 they are doing it. This was done in the year 2003, and I'm not sure whether they are doing it now. Soliton is still available. I'm not sure about Hindustan Pencils. Soliton is still available in the market, and they are number 3 application developers for NI technology in India. All right, so they are still there in there. So someone has asked me, sir, to repeat what is this? So programming part. Okay. Anyway, I'm just gonna continue with the demonstration where I'll show you again something more similar to this. I'm gonna show you. Just watch. Okay. So I'm taking a new VI. So I'm gonna quickly come back to your front panel. I used numeric where I drag and drop a controls and indicators. Numeric controls and indicators. Now I'm going for Boolean. So I have once again controls and indicators. What I'm going to do is I'm going to take a push button. Okay, so I'm going to name it as input number 1. Any name is fine. So once again, one more. I can also do copy paste. Select this, Control C, copy, Control V, paste. Okay, so you can also do these things. Align them if you wish, and you can see here your numeric controls and indicators were orange color, whereas Boolean you can see it is in green color. Okay, so what I'm going to do is I'm going to take a numeric indicator. I'll take a LED indicator. LEDs are usually used for indicating something. So I'll drag and drop it here, and I'm going to name it as output. I'm just using a shortcut name. All right. So what I'm going to do is I'm going to do simple OR gate or AND gate, right? So just watch here. I'll connect from here to here. This is what I was doing last time also. That was addition program where I went to the block diagram, numeric, add function. Now it is Boolean and function. Okay. So from here to here. Very simple. Same like last time. So I'll run it continuously. So off here, the output is 0. 0, 1, the output is 0. 1, 0, the output is 0. 1 and 1, the output is 1. On. 0 and 1 is binary data I'm talking about. Okay. So you're understanding this. If the same thing was with, some other thing, like, I'll just use a XOR. Okay. I can connect it like this. Can you see? Just watch everyone. I'm connecting a node. This is basically called as a node. One thing you have to do is from here, usually you connect it to the terminal. Rather, you can connect it to the wire also by creating a node. So it's a branch node. So the data will flow from here. The same data will also flow here also. Okay. I'll copy paste this also. Control C, Control V. Okay. I'll put it like this. Okay. From here and here, I'll wire it. So this is the AND gate. This is the XOR gate. Let me see if you people can recognize what is this. 0, 0. Sum is 0. Carry is also 0. 0, 1. Sum 1. Carry 0. 1, 0. Sum 1. Carry 0. 1 and 1. Sum 1. Carry 0. So this is sum indicator and this is your carry indicator. Sorry, this is sum and this is carry. Okay. So simple XOR, half adder circuit I was just trying to design. Okay. So one thing I want to show is basically you will see that your numeric will be of blue color. Your booleans will be sorry, your hello. Am I audible now?
Now you are audible, sir. I think the connection has been lost.
Yeah, I lost the connection. I just aborted and just came back. I'm sorry about that.
Okay, sir. Okay, sir. No problem.
No issues, no issues. So you people can see my screen, or I'll share it again. I think this is
You
sharing
share
of
it
focus.
again.
Yeah, okay. All right, I think I'm now live. Yeah, so I was doing a simple half-adder circuit where I was just sending the sum here and carry here. All right, so very simple thing. One thing I want to make you people clear is every data type in Labview has its own color. Okay, so every data type in Labview has its own color. So I'll just quickly come to the slide to make you people understand that. So you can see here there are multiple colors available in Labview. So every data type has its own color, as I told you, right? So your floating point, we saw floating point is nothing but in numeric we have two types. Okay, in numeric we have two types. One is an integer and one is a floating point. Floating point usually takes fractional numbers also, whereas integer takes only whole number. Okay, so you have integer which is blue in color, floating point which is orange in color. Then you have booleans which is green in color. Just now we saw boolean was green in color. All right, then string we have pink in color, and apart from that we also have errors which we will not be using in this course period. The reason is it is something which is much higher end, where hardware interface will come into picture. Maybe in the second class, second session, whatever we plan, which is a data acquisition system. One of my colleague named Rajkumar will be handling it. He'll be demonstrating you people about this error wire. Right now, I'm not going to get much into it, but I'm going to demonstrate all the four other data types. Okay, all the other four other data types I'm going to show you. All right. So before getting into that, any queries about this scalar data? 1D data and 2D data also I'll be coming back to you, because if you are putting up scalar one singular data, then it will be a normal wire. Then if it is 1D, it will be a bold wire, and if it is 2D, it will be a double line. That's how the wires will look like. Wires. Okay, the color and the size matters a lot when it comes to Labview, because it's a graphical programming. So you'll recognize everything based on their appearance. Okay, and as I told you, the connecting terminals, when you touch it, your cursor will turn into a hotspot. Looks very similar to a bunch of wires tied up together. That is how it looks like. All right. So I'll just quickly show you one more new thing. I'll introduce a new thing which is very, very interesting to do. The name is case structure. Case structure. I'm going to demonstrate you case structure. So it is more similar to your if-else case. In your C program, you use if-else, right? It is very, very, very similar to that. So right-click, structures, case structure. Okay, right-click, structures, case structure. Let me try to drag and drop a case structure like this. Okay, case structure. Okay, so I'm going to repeat it again to you people. So on the block diagram, I'll right click, structures, case structure. Okay, so let me quickly tell you about the appearance of this. So you can see that It looks like a photo frame without any photo. It's just a simple frame. And you can see it named as true, and you can switch to false also. So there are two frames. One is true frame and one is false frame. You can do two different logic. You can write a program inside false frame, and parallelly you can write a program inside a true frame. And you have a case selector terminal. Can you see this terminal? This is basically called as a case selector terminal. And the color of the case selector terminal is basically green in color. I'll zoom in. So you can see that the color of the case selector terminal is green color. Okay, green color means Boolean. Okay, so you have to pass a Boolean data to the case selector. To the case selector on the left hand side, you can see of the screen. So you have a case selector which is green in color. So you have to pass a Boolean data. When I talk about Boolean data, it has only two possible values. One is true or false, 0 or 1. I can say that way. So true or false. When true is passed, when the Boolean value is true passing to this case selector, the case selector will select the true frame, and any code inside the true frame will execute, and the other frame, the false frame, will not execute. And any code inside the false frame will be idle. Same way, if you pass a false value here, the true frame will become idle, and the false frame will get active, and the code inside the false frame will execute. More similar to your, for if else. You have a condition, Boolean condition. So if it satisfies, it executes the if case. If doesn't satisfy, it executes the else case. More similar to that. All right. So what I'm going to do is just watch. I'm going to take a numeric inputs. Okay. And numeric indicator. All right. I'm also going to take a Boolean switch, which is going to be a select switch. Okay. So this is going to select me what I want to do. So I'll just name it as a select switch. SEL, I'll just name it. So this is going to be a select switch. Okay. I'll just slightly make the size bigger, so everyone can see what data I'm passing here. So all right, select switch I have. Okay, so what I'll do is I'll place them like this. Okay, I'll keep them outside. I'll tell you why I'm placing them all outside, because these inputs are common to both the frames. If you see that, if I move this A terminal inside the true case, on the false case, I'll not be able to access it, right? So if you move anything inside a frame, that will not be accessible on the other frame. I repeat, on the B, on the false case, if I drag and drop this B terminal, you'll see that I cannot access this B on the true case. All right. So if I want to access it in both the places, I'm going to keep it commonly outside. Okay. So what I'm going to do now is very just simply just watch the select. I'm going to pass it to my case selector. Can you see when I touch it, it is blinking? It means I'm connecting to the case selector terminal. Okay. So which means that if I say true here, the true frame will execute. If I say false here, the false will flow here, and the false gets selected here, and the false frame will execute. Any code inside the false frame will execute. So what I'm going to do is, on the false frame, I'm going to drag and drop a subtract function. And in the true case, I'm going to drag and drop a add function. We did this before, right? So we directly did the addition. Now we are doing, a case selector. Using a case selector, I'm just doing addition if it is true. Just watch, I'm just doing the wiring. Can you see? Yes. So if it is false, from here to here, from here to here, and from here to this terminal, don't create a new tunnel. This is basically called as a tunnel. Okay. So don't create a new tunnel like this. So delete the new tunnel. Control B will delete the wire. Connect it to the same tunnel like this. All right. So now what happens is, just simply imagine what is happening. If I say 10 here, if I say 10 here, and if I say 5 here, and if this is true, for example, I'm just demonstrating you. So what happens is, the value 10 will flow from here, the value 5 will flow from here, and the value true will flow from here, and the true gets selected, and the true frame will get executed. So same data of 10 will flow inside to this terminal, and the 5 value will flow here, and the output of 15 will flow to your C, and the C will update with 15 like this. I'm just demonstrating orally, and I'm just going to execute and show you anyway. So if I say false, same false will flow here, same 10 and 5 here, false gets selected, 10 minus 5 is going to be 5 and the output will be 5, right? I'll just run this program. You'll see that 20 minus 5 is 15. If I click on this, it becomes add. Can you see? So even this value, whatever maybe the value is, just see, right? So it is supposed to, add the data, sorry, subtract the data. 20 minus of minus 10, it is 30. Getting it? 20 plus minus 10 is 10. Let me not confuse you much. I'll keep it like this. So true is add. So 20 plus 13 is 33. So 20 minus 13 will be 7. So this is how you can execute the application. Now, for example, let me say you want to know, usually if you have, your waveform generators, multiple waveform generators where, you have sine wave, square wave, triangle wave, you choose what you want to generate and that particular item gets generated. Those things are all designed basically with this type of logics in software level. Okay. So if time permits, I'll show you that also, but this is how it is basically done. Okay. Case structure. Okay, so I'm going to quickly move into another demonstration. Any query in this? Anyone having any query? Anyone having any query? People can post it if you have any queries. This is a simple case structure. It works exactly like your switch case, like, not switch case, if else. You can make it work like a switch case also, which I'm going to demonstrate next. Any query in this? Anybody? So if there is no much query, I can just quickly move on. I'll show one more example to you people if you want to know how this is working properly. So you just see, I'm going to show you one more data type. I'll go for string data type. String. I use numeric, Boolean I use. Now I'm going for string. Just say I'm going to use string control. String control. I'm going to name it as, once again as input. Okay. IP is input. I'm just naming it as. Okay. Input, whatever name you want, you can type. I just want to say VI solutions. So I'm just naming it as VI solve. Okay, whatever maybe the name it is. Okay, so this input, and I need a output. I'm going to put it this one here. This is a string indicator. I'm going to name it as output. Okay, so you have input and output. Okay, what I'm going to do is the same thing, like how you did for numeric, how you did for your Boolean, how you did for other data types. It's going to be the same here. We have string control and string indicator. I'll drag and drop these two. Now what I want to do is I'm going to check if this input which I've typed is a palindrome or not. So what I wanted to do is I wanted to say here palindrome, PALINDROME. I want to show you that. Okay, palindrome or not a palindrome, I want to show. Okay, so now what I'm going to do is I'm going to do logically. I want to find the reverse of this. So reverse of this is going to be LOSIB. That is going to be the reverse, right? So now what I'm going to do is right click string. Okay, I used numeric, I used Boolean before. Even in structure, I used a case structure. Now I'm coming to the string. In string, what I'm going to use is I'm going to go for additional string function. Additional string function. Only thing you people have to learn is the environment. The environment is what you people might miss. You might not be knowing. So you have to spend some time. You'll understand what item is available where. This is common to all. See, if you're installing a new app in your phone, for example, Facebook or Instagram or like whatever it is. For example, Ola app. Let me talk about. So there, what you do is you first install first, and you'll be struggling, to find the spec, to find the items wherever it is. Then next time what happens is, you get used to it. 4 or 5 times when you use, you will get more used to it, right? So something like that, you should start using this tool more. Then you'll be getting used to it. Okay. So I'll take a reverse string function. Okay. Reverse string function. See, I want to know what does this function do. So you have a question mark here. A question mark, or you can press Control H for help. So when you click it, this window opens. When I touch this, it says, it talks about this function. So by this mean, what happens is you can easily now learn what is this function doing. Can you see when I touch this, it says it's an add function. When I touch it, says subtract function. When I touch this, it says reciprocal. When I touch it, it says round to the nearby. So it will tell you, what is the functions doing. So you can learn all these functions with this guide window. So this one is going to say it produces a string whose characters are in the reverse order of the actual string, which means that if you pass the data here, this will give you the reverse of the same. Okay, so this is what I need. So I'll drag and drop. This reverse function where I get it, string, additional string on the block diagram, not on the front panel. Okay, all the logical items, all the functions, everything is in the block diagram. So right click on the block diagram, functions palette, string, additional string function, reverse string. Okay, so you can use rotate also. The problem with rotate is you have to say how many bits you want to rotate. So that's why I'm not using it. So I'm using reverse. Okay, so now I want to see whether this reverse and the actual data are same or not. Based on that, it is going to be palindrome. If not, it is going to be a not palindrome, right? So what I'm going to do is I'm going to use comparison. I'm going to compare them, right? I'm going to compare. I'm going to use equal to function, drag and drop a equal to function. I'm going to say whether this terminal is same as this terminal. So I'll use once again the context help window to understand how this function works. So when I touch this terminal, you can see the input is x and y. So this function returns a true from the output. You can see the output is green color. Okay, this function returns a Boolean output for the string inputs. Very interesting, right? So this gives you a string, Boolean output for a string input. And you can see this function returns a true if x is equal to y. Otherwise, it returns a false, which means that if this input is same, it gives you true. If the input is not same, it will give you false. Okay, so now once again, I'm going to take a case structure. We saw how to use case structure, right? From here, I'll connect it to this. Right? From here, I'm going to connect it to this. So what happens is, if the input is something like, for example, I'll just type it as I. Okay, so input of I will pass here. This will get the reverse. The reverse is also I, EYE. Both are similar, so true case will execute. If I'm just saying I's, so EYES will come here. Yes, EYE will come here and will measure. It will say it is not same, and false case will execute. Now I'm supposed to send a data which the output indicator will display. To do this, I take a string constant. There is something called constants. Which will not change during the runtime. So I'll take a constant, drag and drop it here. On the false case, I'm going to write it as non-palindrome. Right? So I'll write this as a non-palindrome, connected from here to here. So how this code is going to work? Very simple. So it will measure whether both are same. If false, it will send this value, this string data here, and this indicator will display that. So if not, I'll take one more string constant, drop it here, and I'm going to name it as palindrome. All right. So from here, I'll count it like this. So what I'm going to do is I'm going to run continuously. You can say that for this input, it says it's not a palindrome. If I say something like this, it says it's a palindrome. Right? Getting it? I type a word like this. It says it's a palindrome. I'll just type something like, another word. En something English, right? So you can say it says it's not a palindrome. Right? Yes. Any single letter word is palindrome, because the reverse of that is same, right? So usually single letter word is not considered. Okay. You can do those kind of inputs also. If it's a single letter word, you should not do any logic. Something like that you can give in. Okay. So I'm just trying to show you how string data type also works. Clear? Any queries, anyone? Please post me the query. So I can see people are now just giving feedbacks. That is okay. Any queries, anyone? You can just post some queries, because I like to address a query, because every time when I show you something, you relate it to your works, right? Because when I show something, if it is more related to you, you'll just start questioning. Because I saw one person was talking about FPGA. I'm pretty sure he was working on FPGA. He wants that, so he's asking. So when you more ask question, I can see that you can relating it to your application, and you're asking me more questions. I like that. Okay, so just post me if you have any queries, because I'm now going into one more topic. We have solid half an hour, I believe. So I'm going to a topic which is slightly difficult, or no, slightly hyphened, which makes it little slightly complicated for you people to understand. So I want to clarify all the doubts which you have any. How are we going to use this outside Labview? Good question, sir. I really appreciate that question, Ranjan Kumar. See, Labview is a window where you develop it as a developing media. Okay, so you can ask me, so if this code I develop in Labview, I'm just providing it to someone else, should they also install Labview, and they should also have Labview, right? That's a good question. That is where what we do is we'll develop an application, we convert it into an exe file, and we will share the exe file. So usually every computer has a run engine installed with your Windows or whatever toolkit you come across, okay, whatever OS you come across. So what happens is you share the exe file. The exe file will execute if you have an engine, run engine. Okay, like how we install the software, right? You can also send an application as an installer, so they can install the Labview program and they can run it. So that is how you have to use it outside Labview. So as a exe file or an installer file, you have to use it as such. Getting it? So they'll install, and this application will run, and it will execute. Run engine will execute this code. And you'll see that when you're trying to download also, you'll have an option whether you want a run engine or you want a Labview developer window. Okay, when you install, I'm going to share you one new thing. So, okay, someone is saying, no, once you are trying to run it without Labview, okay, nice. Exe file doesn't need Labview actually. You're right. You have done the right thing. I think you have faced some issue. Please let me know what is the issue you faced. Oh, okay, you face a problem. What is that?
Sir, good afternoon, sir.
Yes, sir, please.
Actually, like I was creating an exe file through Labview for a particular application, but when I was running that, it was saying like it needs a Labview platform base.
Yes, sir.
I just copied that and I just run it in another window, sorry, another laptop. Yeah. But unfortunately, I was not able to run that exe file, sir.
Yes,
is there
sir,
any other settings which I should
I understand.
make?
I understand. What is the problem you have faced is your system didn't have a run engine for external, applications. See, usually Windows, what they do is in the recent time, they have stopped much of the, prompts. Usually, if there is an external thing, right, it will ask you a prompt saying that, do you want to, do this installation or things. Now they have removed all those things. That's a problem. So in that case, what you have to do is, you have to install in that system, in the other system where you want to run the application, right? You have to install a Labview run engine, not Labview program, Labview run engine, which is actually free of cost for everyone. Okay. So you can procure Labview and you can do the development. Okay. And if you want to share this application to someone who doesn't have Labview, you should ask him to install a run engine. Or one second best way is, if you're having a development system, you're developing this Labview, don't create exe, create an installer file. Okay, sir. Create installer file. Installer file has an inbuilt run engine to be installed in their computer. So anyone is installing this code, as an installer. So what happens is the run engine also get attached to it, and both will get installed into their computer.
Okay, sir. Actually, like what happened is like the lab servicing technician who brought us the software, right? Okay, he was having this sort of run engine, I think so, and he was giving us our own the Simulink for our lab setup, and like I was trying to rebuild that one. When I was doing that, I was not able to run this exe file. That's the problem.
I think there is one more person also has the same question related to the same issue.
Thank you, sir.
Based on Simulink only. What you need is, if you are getting this problem that's saying that the platform is not available, it means that run engine is not available. Platform is nothing but to execute that particular software, you need some engine to execute it. Labview is also a developer engine which will execute the application. If not, use a exe file engine. Or rather than using a exe file, use an installer file, because automatically it will have the the run engine attached to it. So you don't have to manually go and install the run engine. It will automatically get installed. That is what I'm trying to say. If you use an installer file. Clear, sir? Great. I think you people are using Labview already. I'm really glad about it. Just come up with, whatever application or whatever issues you have. I'm really happy to answer them all. Thank you. So if this is clear, I'm just going to the new topic, which is going to be slightly, to my perspective, the more advanced you go, the more interesting concepts you explore. That's what I always understand. Because why there is advancement? Because there is something you can do something better, right? That is where I feel when you go for advanced concept, I'm going to show something very interesting to my perspective. I can't say that it's going to be interesting for all, but from my perspective, it is very interesting. I'm going to show you that. You see, I'm going to use something called as loops. Okay, so case structure you have something apart from that you have for loop and a while loop. I'm going to show demonstration about them. A for loop, while loop is very simple, like how you use it in C program. A for loop runs for a particular amount of time. That's why it is for loop, for a finite amount of time. So you specify what is the n value, n equal to, you specify some value. Based on that count, the loop will iterate for those many number of times, and it stops automatically. All right. So very simple. Then comes a while loop. Usually, if you see other programming language, you have two different types of while loops. Okay, one you have is a normal while loop, and you have a do while loop. All right. When it comes to Labview, you have only one while loop. Namely, it is named as while loop. Okay. Whereas performance-wise, a while loop in Labview works like a do while. I repeat, you have only one while loop. The name of the loop is while loop, but it behaves like a do while. What is the difference between a while loop and a do while is usually these while loops, both while and do while, they basically have a condition to check. Okay, so if the condition satisfies, it executes the code, or in the other way, if the condition satisfies, it will not execute it. It is up to you how you want to configure it. Okay, but if the condition satisfies, it executes. If the condition is not satisfied, it will stop there. Okay, so it has two tasks to do. One is condition checking, and one is executing the actual task. Okay, so based on the condition, it will just execute or it will stop there, right? So now, when it comes to while loop in Labview, works like a do while, which means that it first do. The name itself says it's do, which means that it will execute the task first. Then it will come and check that task. I mean the condition. So that's what is called as a do while. So it first executes the task once, then check the condition. Execute, check condition. Execute, check condition. The other way is normal while loops. How they work in C program is it checks the condition. It checks the condition and then go for the execution. Check condition, do the task. Check condition, do the task. So it is ulta. So this happens first and then that happens next. All right. So these are the two loops we have. I'm going to drag and drop both the loops in Labview. They are more similar to your, how your case structure was looking. So this is a for loop. I'll give a label for loop and visible item label a while loop. A for loop and a while loop. Okay. So what are the things you have in common? Only one thing you have in common is I terminal. This I terminal stands for iteration terminal, loop iteration terminal. Okay. So loop iteration terminal, you cannot control it. Very important. Very important. You cannot control it. There is no control for this. So you cannot control it. It will automatically update. Usually, if you see in a C program, you increment the iteration, I++ increment, right? So what happens is after executing one iteration is nothing but on that instant is doing some task, right? That is called iteration. The loop will iterate multiple times. Okay. So on that iteration, you will, after finishing that iteration, you increment it. So it goes for the next iteration. If you don't want it to go, you don't increment the iteration. Okay. So there you write a program in such a way that whether the I values, reaching the n data. So n data and I data are same, then you don't increment, right? That is how we write the program here. Here we don't do that. Rather, what happens is this I value will automatically get updated. So first iteration, it shows 0. In Labview, everything starts with 0. In this platform, everything starts with 0. So first iteration, the I value will be 0. Second iteration, the I value will be 1. Third iteration, 2, 3, 4. It keeps on going. And at the last iteration, and let me say the loop is iterating for 100 times, the last value it will show is n-1 always. The reason why it always maximum value the I can display is n-1 only, because it starts with 0 and goes till n-1. Okay, so it starts with 0 and goes till n-1, and it's the same for your while loop also. The iteration works the same way. When the code is executing, until the condition satisfies, the I keeps on incrementing. Okay, So loop stops while the condition satisfies. I repeat, you're going to create a condition. So, and one more thing, just make it clear. I'll make it clear to everyone. Just note it down, everyone. In Labview or any platform, when I talk about condition is usually booleans. Don't get complicated. Don't get it complicated. So when I say condition, it should be usually booleans only. Yes, the condition is satisfied, or no, the condition is not satisfied. So keep it simple. Usually your booleans takes care of your conditions. All right. So right now I'll demonstrate this for loop later. I'll come to the while loop. It's very simple. Okay. So I'll create a control here. So it's a while loop condition terminal. This is a loop condition terminal. This is the iteration terminal. That is all you have for while loop. Okay. So I'll right click, create control. You can see there is a stop button. A stop button. Okay. So what is this while loop is going to do is any code inside, if you draw it, that particular amount of, that particular code will iterate for the many times for n number of times till the condition satisfies. I repeat, how this while loop works is very simple. You can write any code inside this while loop, and that particular code is the task to execute. That is a task to do. So that particular code inside the while loop will iterate many times till the condition satisfies. What is the condition? Here I've created a stop button as a condition. How I did? Very simple. I'll delete it and show you. Right click on this terminal, create control. Because I want to control the loop. I want to control the condition of the loop, right? So I'll create control. So you'll see there is a stop button being created. So now clicking on this stop button is the condition I created. It can be anything. You saw, I was creating one more case structure, like, finding the reverse of the string and matching whether they both are same. And if they are same, based on that, I was executing a true frame or a false frame. Those kind of conditions are also right. That is also a condition. So even here you can have a string data, reverse of the string. If they are same, that is the condition satisfaction. Everything is fine. Okay. So right now I've done a simple button. So what I've done is when I run this program, when I click on this stop button, it means the condition satisfies and the loop will stop. Okay. Fine. What logic I'm going to do? Very simple. I'm going to keep on doing simple logics always. I'm going to take up input number A and input B and an output C as an indicator. All right. So same logic, adding from here to here, from here to here, from here to here. Clear? Yes. So now you know that running continuous will update it spontaneously, but now I'm not going to do that. I'm going to give the data, and you'll see that I'm going to run single time, not continuous, single time. You'll see that the code is iterating it many times. The code is executing again and again. Okay, the code is executing again and again. Any changes I do, it is spontaneously updating. Usually this doesn't happen. Usually when you run it once, it executes once and it stops, and you change the value, you run it again, it works. But now how it is working is because you have enclosed it inside a while loop, the VI is running once, but the while loop and the items which is drawn inside the while loop are iterating many times. Okay, so it keeps on iterating. It keeps on iterating, and you can ask me how much time it will iterate, sir? It keeps on iterating for infinite time if the condition doesn't satisfy. Here, the condition satisfaction is nothing but it is working here. If I click on the stop button, the loop will stop because the condition here to stop the loop is stop button. So when I click on the stop button, the loop stopped, and any code inside the loop stopped. So now what I'm going to do is I'm going to show you one more demonstration. Let me say, now you can see that any changes is not working, right? So now what I'm going to do is I'll take one more set of the same code, Control C, Control V, like this. So you can see same code. This one is inside while loop. This set of code is outside the while loop. Can you see? This is inside the while loop. This is outside the while loop. I'll give some random data, 1, 2, and this is going to be 3, 4, for example. Okay, here also I'm going to say 4, 5, 6, 7. For example, random numbers I'm just giving. So here, just watch everyone. Just watch everyone. When I run it once, both are executed. 45 plus 67 is 112. It is showing that. 12 plus 34 is 46. Both are executing. You can ask me what is the difference between them. There is a difference. You see that since it is run once, this has executed once and stopped. any changes I do, you can see the output is not getting updated. Any changes I do, the output is not executing because I told the loop, the entire VI to run once. It has done the task. It has added the data, it showed it 46, and it has stopped there. Whereas this particular item, which is enclosed in a while loop, you can see even with the single run, any changes you do, it is still updating. Whereas which is kept outside will not update. That's a huge difference between them. So you can segregate which item to run once, which item to run multiple times. You can segregate that in Labview. Clear? You're understanding this? Yes? So why a while loops to be needed? You can specify what subset of the code or in the entire big VI, you can do a huge amount of codes inside. Okay. So you can specify which particular item should execute multiple times, which item is not to be executed multiple times. You can specify that. So if you want to stop, click on the stop button, the loop stops. Clear? Yes? So if this is clear, I'm going to do one more thing. Any doubts, anyone? Any queries? There seem to be some query. No. Oh, they shared the feedback. Okay. So any queries, you can just post it if you have. I'm just going to show something which is my favorite thing about NI technology. I'm going to show you that. Okay. So just watch. I'll close all these codes. I don't want them. This is okay. I'll just minimize these codes. Okay. I'll minimize all them. I'll take this here. Okay. So just watch. I'm one thing. I want to take a while loop and create a condition. And need not be such a big while loop. I can keep it small. Okay. So one small loop, and I can put any code, you know that, but I'm not doing it. I'm going to demonstrate something. I'm going to create an indicator to this iteration terminal. Okay. So I'm going to name it as iteration. I'll just name it as I for iteration. Okay. So it's an iteration terminal. Name it as small I. Okay. So iteration terminal you have. Okay. So I have iteration terminal. Just watch here. How this is going to work, I told you. When the loop is iterating first time, it shows 0. Second time it iterates, it shows 1, 2, 3, 4, 5. It keeps on executing. It keeps on iterating till what? Till the condition is satisfied. Slightly make it bigger so you can see the values. All right. So I'm just making it bigger so you people can see the value. Okay. So I repeated how it's going to work. The loop is going to iterate multiple times. It keeps on executing till I click on the stop button. The loop will keep on executing till I click on the stop button. So first time when the loop iterates, it shows 0. Second time it iterates, it shows 1. Then it shows 2. Then it shows 3. It keeps on going. All right. You understood how this works? If you understand this, just watch it. When I run it, okay, you'll see that it is running multiple number of times. It's running multiple number of times, and I stop it. It shows something like 1, 10, 100,000, 10,000 lakh, 10 lakh crore, 10 crore. It says that the loop has executed 10 crore time, 18 lakhs, 10 crore, 18 lakhs, 65,314, not 13, because I told you it's from 0 to n minus 1, right? So the loop has stopped at this number. It means that it is plus 1 times it has executed. So I'll just run it for 1 second, just see. It already says that it has reached 83 lakhs 15,370 times. All right. So loop is this fast actually. The loop is this fast so that if you don't want it to run this fast, you can control the speed of the while loop. In 1 second, I'll quickly stop. You can see. In 1 second, it is executing this much time. Any code inside this will iterate those many number of times. Okay, so I don't want this to run at this speed. So what I can do is I can go to timing. Okay, so I can go to timing and I can take wait millisecond, drag and drop it inside the loop, and I can specify at what speed it is supposed to execute in millisecond. So if I say 1000 millisecond is equivalent to 1 second. If I say 1000 millisecond, now the loop will iterate once in 1000 millisecond. In other words, I can say it is going to execute once in 1 second, right? So when I run this program, can you see? Yes, it is keep on iterating, and it keeps on iterating till it condition satisfies. And what is the condition? I'm sorry, I think it is news update is Okay, so it keeps on updating till the condition satisfied. What is the condition? Clicking on the stop button. Okay, I'll click on the stop button. The loop stops there. Getting it? Yes, this is the controlling of the loop speed. If I just say this should be 500, 500 means it executes once in 500 millisecond, which is equal to half a second. So you'll see that the loop iterate is pretty fast. So it is executing twice in a second. Okay, it's executing twice in a second. I'll just go something like, smaller value like 10, which means that the loop will iterate once in 10 millisecond. So it will iterate 100 times in 1 second, right? You'll see it will iterate 100 times in a second. So this is how you control the speed of the loop. Okay, this is how we control the speed of the loop. You can ask me, what is the point in controlling the speed of the loop? When it is running faster, it means that it is doing the process faster, which means that the response you get is faster, right? So that is what everyone wants. Everyone wants the application to execute faster, get the response faster. Any logic you do, any controls you do, it is giving the update faster. Everyone wants that. What is the need for doing this kind of logic? I'll delete this and show you what is the need. Okay, so when I run this program, you'll see that this is the uncontrolled speed, very fast, without any delay. I'm showing you. Can you see it is running at this speed? It's very fast. Okay, good, nice. I'm not saying anything. So just see, I'm going to open my task manager. Right click on the bottom. Can you see this? No, bottom. I'll just say task manager. That's a task bar. Right click on the task bar and say open task manager. You can see these things are like running behind. I'll come to the performance. You can see that my CPU is being used for 18%, or like, here you can see 18%, 16% utilization of my CPU. Okay, so CPU resource is being used for this much amount of time. What I'm going to do is, already there are some applications running, like, my browser is open. I'm just talking to you people. So the browser is also working. My Wi-Fi is working, right? All these things are running behind. So you can see normal state, it is nearly taking 20. Let me say, approximately my CPU usage is 20%. But if I run this program without a delay, a while loop, you'll see the CPU utilization shoots up. It shoots up to nearly 30%, maybe. From 20, it has gone to nearly 50, right? From 20, it has gone to 50. And when I click stop, just watch everyone, it comes down exactly to the normal state. The 20% normal, that was a normal state because other applications were running. For that, it is utilizing 20%. That's all right. All right. So once again, if I run it, just watch. Once again, when I run it, it will shoot up, right? So if you ask me what is it happening, why it is happening, see, Labview's running. There are other applications also running here, which means that you can see that process. There are a lot of applications running here. Can you see these are the applications that are left open and it is all running? Great, nice. Apart from these apps, there are some background processes running. There, as you can see, there are a lot of background processes running. I'm glad these processes are running. I'm glad. Okay. See, they are not using any of your percentage, even though they are running. 0.2, this application is dragging, 0.2, and it is now 0. None of them are running, consuming my memory. Only this is consuming more memory. Can you see? This is consuming more memory and CPU usage. Okay. So now, if I run this, you can see Labview started using more. 28% or 30% is being utilized by Labview itself. So what is it exactly happening is, you're executing the while loop. While loop is running this fast. I repeat, you're executing the while loop and while loop is doing this fast. And there is a task assigned for the while loop. What is the task? Here we have not put any task. There is empty loop. If there is any logic inside, it means that there is some task to be done. Here there is no task. There is no point in running this, but still we are executing it. Okay, so there is a task it's supposed to be executing. So what is happening is the loop is iterating very fast. So this Labview loop is going to the processor and asking, I have a task, complete and give me. Okay, whatever is the task, it will finish and give you back. Once again, it is sending a command or it is going to the processor asking, I have a task, complete and give me. I have a task, complete and give me. I have a task, complete and give me. So that is doing it this fast that your processor is already 30% tired because of your Labview, a simple while loop of a Labview. It is pretty fast. Because these are like designed for industrial format or industrial standards into industrial controllers where the speed is needed. So it is made in such a way it tries to drink most of your memory usage or the CPU usage of your computer, consuming this much memory. So to avoid this, what we have to do is, to avoid this, you're supposed to bring a delay. But before that, I'll also show you one more nice demo to you. I'll copy paste one more. I have copied paste one more set, 2 loops now. So when I run this program, before it was, now we can see it has gone to 80% nearly. Each loop is consuming 30%. So it's 30 plus 30 is 60 plus normal 25. So now let me say what happens if this reaches 100%. One more while loop is easily is going to touch 100%, right? So once it touches 100%, what it means is your CPU's memory, the CPU utilization, your processor is 100% utilized. So there what happens is if you try to open any other app or any other application, what happens is it will say not responding. Have you ever seen not responding at the top? That not responding means that you have requested, this app has requested a command, or it has requested a service from your processor, but the processor has not responded to it. Okay, why it is not responding? Some culprit like Labview at the background, it is consuming this much memory. And because of that, the CPU is already 100% and it is not able to execute anything. So what we people do when you see not responding, we keep on hitting the button. Close, 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 close. We get irritated, sometimes frustrated, and we keep on hitting it. That is not the right way to do. It is already saying, it is so sorry, it is a pathetic fellow. It is already saying that, see, I'm trying to do something, but the processor is not responding. But if you ask me one more request of close the button, the 1 second processor is supposed to respond to it. It is not going to respond, right? It will not be responding. So basically what happens is when you see not responding happening, open the taskbar and see there should be some culprit like Labview who was doing now. Now you can see it has already gone to 0% because I stopped them all. Okay, so try to end that particular task. If I click on end task, this particular set of code or set of an item or set of an app or background process, whatever it is, that will get eliminated, and so other applications will freely run. This is the reason we came to embedded application. Many people might think, why embedded application is here. Embedded application or real-time application, why it is called as a real-time? Because here you can see that I can't use the real speed of my loop. The real speed of the loop is this much. Okay, the real speed of your loop is this fast, but I don't do that. If I do that, I know that other applications might hang. So what I am supposed to do is I'm supposed to use a delay and reduce the speed at which my my loop is gonna ask for a service request to my processor. I'm slowing it down. Some number minimum I can give is only 1 because time, right? I can't give a negative. And or I mean you can see by default it is blue color. I told you what is blue color. It is integer. I can't give 0.1, 0.5. I can't give. So the minimum I can give is 1, which means that this is a controlled pace. So now you can see the loop performance. Let it saturate. Let it saturate. You can see it is still around 60 only. I mean, sorry, 20 only. Okay. It is still around 20 only. Because you are reduce the speed of the loop to go and request for a service by introducing a delay. By doing that, what happens is now the CPU is having enough time to handle the other applications. So other applications will never say not responding now because of Labview. Because of Labview, they won't do it. If there is any other problem, yeah, you might come across not responding. Now you see Labview is, even though it is running, the loop is pretty faster, but you're not allowing the loop to run in real-time speed. The actual speed of the loop is not done. The reason why we don't allow it to run in real time is it might kill the other applications which is running parallelly across it. That is where we go for embedded system, where we embed the code, we deploy the code into the processor. There, the processor has to take care of only that particular task. There is no parallelly one more task running. Here, this is a general purpose computer where I can download, I can listen to music, a gaming can run, Parallelly, I can browse something, some download is happening. It can do any process parallelly. Meanwhile, I'm doing industrial application also. I can't allow the industrial application to run at the actual real-time speed. So what is going to happen is it will kill the other applications. It will try to kill the other applications, or maybe other applications might kill my task. Maybe, who knows, right? If there is other applications just consuming more memory, my application will not respond very quickly. That is why we go for embedded application, where in embedded application, you'll see that you can allow the application to run in real-time speed. That is what is called a real-time application. Okay, real-time application is you can embed the code into that particular process, and the processor will take care of that particular application only. Whereas that is not the right thing to do when it comes to a generic platform like your general purpose computers. You're understanding what is the purpose of embedded system. From there, there are also one more complications. You feel like there is no parallel communications happening in your RT application. That's where we go for FPGA. I'm not getting into that loop of comparing RT and FPGA. There is a reason why you go for FPGA, which I'm not talking to you all about. But I'm trying to tell you people, from a normal computer processor, which we have nowadays, with the processor computer, what we have is i5 processor, i7 processor. They're very powerful, very, very powerful. But still, we don't do all the industrial application on those laptops or those computers. We go for embedded application, where there's a processor will do only one particular task, dedicated processor to do the task. No sharing or no allocation, or there is no priority there. No, these kind of not responding or no memory usage or utilization issues will not have there. Clear? Yes. So I think it is already 4. Any queries with this, whatever I'm doing? I'm just wanted to show what is the need for a delay. Every time when you use a loop, while loop especially, because infinite time it is going to run. We don't know how much time it is going to run. It might kill any of the applications. So always run a while loop with a delay, minimum of 1 millisecond delay. Okay. If not, it will kill your CPU's utilization. CPU's resource will be killed badly. Clear? So if this is clear, any queries, anyone? With this, I'm just going to end up the session. We have, I'll come back to you people once again. If you want, I'll just show my contact details to you people, so that if you have any queries also, you can feel free to just ask me. So this is my contact detail. You people can feel free to reach me. I'm also going to send you people another link. Me, or if if there is a person who's interacting with you from the college, ACS college, they'll be doing it. So they'll be trying to reach you people for a new link which will work. You can install it, and you can download it and install it, and just try all these things which I showed you. We'll come back to you on day after tomorrow, where we'll be demonstrating you people how to interface a hardware and acquire a data and show you. Okay, maybe you don't have the hardware, but you can simulate those hardware. NI hardwares can be simulated. So they'll be showing you how to simulate the hardware, and you can try them. And then I'll be coming back to you people on last Friday morning, maybe around 9 o'clock. I'll be coming back to you people, where I'll be showing you people about what is Industrial Revolution 4.0, what companies are trying to do about Industrial Revolution. I'll be talking to you all about, right? What is smart factory? What is the criteria? What is the standard? Why to do it? What is the reason to do it? To do it, what you need it. So all these things I'll be telling to you about. All right. So thank you so much. If you have any queries, I'll leave the dais open for you people to ask queries, and I'll be happy to answer your queries. I'll stay in the call for some more time, so that you people, if you have any queries, please let me know. You can unmute and ask me if you wish, or you people can just ping me. Any issue, no issues. Any queries, anyone? If there is no query, I can just leave it open to the the organizer. If they have any other instruction to give you people, I'll leave it open to them. Thank you so much. Have a nice day. Stay safe in the COVID situation. All the very best. Try using this a lot. In case if you're having any error, any problem you're facing, please let me know. All right. You're always welcome, sir. Thank you so much, everyone.